So cholesterol, you probably heard a lot about that. There's all sorts of ads out there that says lower your cholesterol with taking these drugs, and it's something that the health industry is super focused on. But we always need to look at actual evidence when it comes to what really creates risk for coronary artery disease. So a big study that came out recently looked at all sorts of factors and really tried to hone in on what the issues were that led to higher risk for coronary artery disease. And if we look here at this chart, we can see cholesterol is here, hypertension or high blood pressure is here, body mass index. I'm sorry, body mass index, which is your level of being overweight or not. And this is the over here you see the association it has with having coronary artery disease. So it shows those are all just about even. Family history is down here. If you have diabetes, if you smoke, is down here. What really stands out, your number one, actually, this one's a combination of the risk factors plus the genomic risk score. You can see that this genomic risk score is quite a bit higher, significantly so. You see it's above these error bars. These error bars do not overlap. So significantly, these genetic factors that are partly based on your family history, but not necessarily are really what can lead to a higher risk of coronary artery disease. So as far as the data, the best data we know, it's not so much cholesterol, but it's a host of different factors, and that's difficult to get down. I can understand why cholesterol is easy to measure. So we've been doing it for a while, but the genetic score is kind of tough to nail down. You can't do anything about it. So as humans, we like to identify things we could do something about. So I think that's why cholesterol is focused on so much, even though it's not really the best. And here we have some explanation of that. A lot of studies just focus on total cholesterol, but it's really only the low density lipoproteins that are LDL, which is, we would say, bad cholesterol. Bad under quotes. HLD, high density lipo, HDL, should be HDL. I switched that around. So switch that to HDL, high density lipoprotein. That's called, you've probably heard of good cholesterol. And it's associated with a lowering of your heart disease risk. And what they'll do is tell people to stop eating cholesterol, but when they reduce their dietary intake, they usually don't see much of a decrease in their cholesterol levels, and that's because the liver makes cholesterol. So if you eat less, your body just makes more. Your body has a kind of set point that just genetically and naturally you're at. And as we mentioned in the last one, your genetic factors have shown to have a more powerful effect. And when it comes to, if you really want to lower your cholesterol, drugs are better at reducing it. But again, is that really a necessary thing to do, given that we don't see a huge association? That's something that hopefully medicine will come up with a better answer for in the future. And remember, drugs, any kind of medicine you take, you're going to be running risks of side effects. So here are interesting cases that have been studied rather extensively. Native American, here's a Native American woman, represents a group of people that were given a high carb diet and ate no cholesterol. So really ate no cholesterol, no animal fats. I'll add that animal. And as you can see, this group of people, several dozen, became very obese. and that kind of goes counter to what the diet experts had thought of. And this is a group of people. They're Maasai people over, I believe it's not Kenya, but I'll have to come back to it. I'll write it down here later. But they basically eat only meat. Animal fat and a fair amount of blood. And they have very low cholesterol. Almost no heart disease. Which is also very tough to explain if we're saying for 50 years, 60 years that you eat a lot of meat, you're going to get heart disease. Well, not these people. They don't seem to have a problem with that. So one thing that was interesting, they said, well, maybe they have some weird genetic mutation that allows them to fight it off. So it's not really, animal fat is bad, but they're just immune to it. But no deal on that one. When they've tracked Maasai that have moved to cities, moved to urban areas, in a country, right? Tanzania, I think it's Tanzania. They moved to cities, large cities, and changed their diet and started to eat more carbohydrates, less meat. They got heart disease. So they moved to cities and got heart disease. I'm going to say HD, heart disease. So it's not 100%, but we definitely know that, based on these several hundred people that they tracked, that clear link between animal fat and heart disease is very, very problematic. And we still don't really know how to explain that. Another thing that's really hard to explain that nobody's really dived into is this is a very high quality study because they were able to really control veterans that lived in the LA Veterans Hospital. I think this was the 40s, and they fed the experimental group a low fat diet, or low fat, low animal protein. And the control group ate regular diet with, a mixture of plant and animal protein. But this experimental group is plant-based, or carbohydrate, sorry, and low animal protein. And they didn't really see much difference in their heart disease levels. There's really nothing. So they stopped the study, but they continued to track them. And over time, they found a significant increase in carcinoma deaths, so cancer. So they may not have made a difference for heart disease, but there is this good evidence that it increases cancer rates. This special low fat, low animal protein diet, low cholesterol. So, and that again still hasn't been adequately explained. So a lot of our paradigms and our just fundamental so-called beliefs about diet are really problematic. It's just tough to get good data on humans and diets because humans aren't good at following directions and being honest about what they eat. So you can determine the energy content in food by combustion, burning it. So you take your food, you weigh it before, you get the temperature of the water before, and you burn it, and then you measure the temperature after, you measure the ash weight, what this measures afterward, and you can calculate the energy content. So we'll do that here. And you use this formula here, mass of water times the specific heat of water. I'll write that, specific heat for H2O times the change in temperature. And then you divide that all by how much was burned. So mass of water in here, 10 milliliters. 1 milliliter of water equals 1 gram. So that's pretty easy. So we have 10 grams times 4.816 times the change in temperature. So you got to take, what was it? 67 minus 25. And when you do that, you get 42. So you multiply these together, I did earlier, you get 1,758.12. So 1,750. So that's your kilocalories is the unit, and I'm not doing a good job with the unit conversions here. But that's your raw number of calories. But we need to know, we want it per gram. How many calories per gram? So we're going to take our 1,758. By the way, just kind of in a rush and being lazy right now, but just take your calculator and check that for me, because the numbers I wrote down from last night might have been wrong. And if I subtract 1.34 from 3.12, I get 1.78. And if I divide my total kilocalories by the mass, I get 987.7. My face is in the way here, so I'll just write the unit here, kilocalorie per gram. So you should be able to calculate that. It's not too big a deal. And remember, on the exam, if you ever had to do that, you would get the equation. So don't worry about memorizing that. Click on the link that you see on the slide to get your meal plan plate. I think that's what it is. So for me, I'm 45, male, 208, 6 feet, 5 inches, and I'm pretty, I do pretty good exercise there. So click calculate. It'll tell me how many calories if you are aware of how many calories they tell you to have. Usually it's around 2,000, but because I'm taller or bigger, they say to keep what I have. Plus, with all the exercise I usually do, 3,000 calories is what I would need. And if you click on the where it's linked up there, it gives you kind of a breakdown. So out of the 3,000 calories, this is what it says I should do: 2.5 cups of fruit, 4 cups of vegetables, some ounces of grains, protein, dairy. And this can be helpful just to kind of get a sense of it. Remember, they usually still favor these a little heavier with the grains than they need to, especially for you younger teenagers. Dairy is really important. They're really finding out that you need to get all that vitamin D, calcium, potassium, and go to the bottom, click on action plan. Kind of gives you more tips and everything. So I will definitely need to explore that and then write about what you find out. So just go through that website and kind of give a description of diet, maybe if you're comfortable, number of calories it says you should have, and just kind of a rundown of the the fruit, vegetable, protein, and whatnot they want you to eat. And anything that, write down anything that surprised you, something that you thought you already knew. Oh yeah, I knew that. So just give it a little description of what happened. So in IB, we always strive to be international mindedness. So kind of look in the World Health. World Health Assembly, I believe, is part of the World Health Organization, but they have a program. It's pretty awesome. They've had it for a while, but they just revamped it to track, global health of in terms of vitamin. So global health in terms of vitamin access, I guess you would say. So these sorts of data are tracked by officials that take a country by country survey. And this kind of gets into, you think about, countries have to cooperate. So do all countries cooperate? I'm not sure. That'd be an interesting thing to find out. And that might be an interesting IA topic. I know most of you have already decided on yours, but yeah, you could definitely do a study on that. And theory of knowledge, this is interesting. So you need vitamin D, but there's a health risk. So it's not really a conflicting knowledge claim, but there needs to be balance in anything. You just think, yeah, you need vitamin C, but too much can really harm you, can really burn out your kidneys. So there just has to be balance in our knowledge. We can't, if something confuses us, we can't then throw all of our knowledge away. If it confuses, we can't go into a state of disbelief. Not into. And that happens a lot of times in science, but they say, oh, the scientists said this, and now they say that. I'm not going to believe anything. Like, no. Scientists are just clarifying what they're saying. A lot of times you see in news reports, they'll be very sensationalistic, and it won't be really representing what the scientists came up with. They don't write the headlines. Not even the journalists, the bosses of the journalists, the people that are looking to sell papers, write the headlines. So just remember, your TOK, you're always getting to discuss things that are contradictory, gray area, and in science we have that as well. Vitamin D can be gained by exposure to UV rays, but too much UV rays can be harmful.